त्यांचं सगळं इथे लावायला मला ॲडजस्ट करायचं.
गुड मॉर्निंग यासिर जी.
बंद करते सांगते. ओके यासिर, I can start now. Okay, I will not wait for others. Okay, so
Yasir, like the video.
okay, write down the questions. A man has pulled a cart. Write down the question. A man has pulled a cart through 35 meter through 35 meter, applying a force of 300 newton. Applying a force of 300 newton. Find the work done by the man. Find the work done by the man. Okay, I'll repeat this question one more time. Here question is given, a man is pulled a cart through 35 meter, applying a force of 300 newton. Find the work done by the man. Okay, so here force is given, that is nothing but 300 newton. Okay, and displacement is given s or x, that is nothing but given 35. Okay, 35 meter, correct, 35 meter. So they are asking here find out the work done. So very simple formula, no? Work done is nothing but what? Force into displacement. So we can write work is equal to force into displacement. Force is given 300 and displacement is 35. Okay, so if you multiply this, you will get the answer 10,500 joule. This is the work done. Getting? Okay, very simple problem, 1 mark. Maybe they will ask for MCQ. Copy this. Okay, I'll repeat this. A man has pulled a cart through a 35 meter, applying a force of 300 newton. Find the work done by the man. Okay, and take a screenshot of this. Okay, write down one more question. Write down next question. A block weighing 20 newton is lifted 6 meter vertically upward. Calculate the potential energy stored in it. Calculate the potential energy stored in it. I'll repeat this question. A block of weighing 20 newton is lifted 6 meter vertically upward. Calculate the potential energy stored in it. Okay, so here this is easy problem, but this is potential they are asking, potential energy. We know that potential energy is equal to mgh. Okay, but here we have a ground and that object is placed here, but afterwards it took lifted up. Okay, so its weight component mg is acting vertically downward, and that mg is given here 20 newton. Okay, that is given 20 newton, and here the displacement, vertical displacement, this is s, that is given 6 meter. Okay, 6 meter is given. Then mg is nothing but 20, and s is nothing but here vertical height, that is nothing but 6. So answer is 120 joule. Okay, getting this kind of questions. समझ में आ रहा है सबको? Okay. Copied. Okay. Chalo, next question. Write down. Everyone is getting, those who joined. Okay. Write down next question. A 500-gram stone. A 500-gram stone is thrown up with velocity of 15 meter per second. 15 meter per second. Find its potential energy at a maximum height. Potential energy at its maximum height. Second, kinetic energy when it hits the ground. Kinetic energy when it hits the ground. Okay. So here I will repeat one more time. A 500-gram stone is thrown up with a velocity of 15 meter per second. Find its first potential energy at its maximum height and second kinetic energy when it hits the ground. Okay, so here this is little bit conceptual question. Okay, but it is quite easy. So here whenever you are throwing any object in the upward direction, okay, suppose this is a stone initially on the ground and when you throw vertically upward, then stone comes here. So in that case it possesses the kinetic energy will become 0 and it is what becomes momentarily at rest, and in that case here loss of kinetic energy at this point, loss of kinetic energy is equal to what? Gain in potential energy. This is very important. If you comes to know this, then it is very easy to solve. They are asking here first potential energy at its maximum value. Okay, so here we can write potential energy is nothing but kinetic energy at final minus kinetic energy at initial. Okay, so initially it is at the ground and we thrown, and when it reaches to certain height, then its velocity becomes what? 0. So if I expand this, half mv square minus half mu square. So this v will become 0, okay, because when it reaches at particular height, this velocity will become 0 into half minus half. Now mass is given, no? Mass is given I think in terms of gram. So 500 gram is given, okay. So gram is there, we have to convert this into kg. So just you can divide this by 100, okay, sorry 1000. So it gets converted into kg. So here 0.5 kg is the mass. So multiply here 0.5 and what is the initial speed? Okay, initial speed is given, no, it is traveling with 15 meter per second. So you can multiply with 15 square. So here minus half into 0.5 into 225. Okay, and if you multiply and if you do this calculation, you will get the answer minus 56.25 joule. Okay, so this is nothing but what your potential energy. Getting, otherwise you have to use the kinematic equations and then you can calculate the potential energy because H is not given or S is not given. Okay, so by using kinematic equation also we can find out this. And if we take this concept, loss in kinetic energy is equal to gain in PE, that is also correct. Getting this? Then they are asking next part, that is kinetic energy when it is at ground. Then it is easy, no? That is also same answer you will get, kinetic energy. So this is kinetic energy, no, when it is at the ground. So same thing you will get but with positive sign. So 56.25 joule. This is what the answer for this. Can you getting this? Can you getting? Take a screenshot of this. Take a screenshot or you can copy fast. Copy fast. Okay. Chalo. Write down next question. On reaching the top of slope, write down on reaching the top of slope 6 meter high. 6 meter high from its bottom, a cyclist has a speed of 1.5 meter per second. 1.5 meter per second, full stop. Find the kinetic energy and the potential energy of the cyclist, full stop. The mass of the cyclist and his bicycle is 40 kg. Okay, so I will repeat this question. On reaching the top of a slope 6 meter high from its bottom, a cyclist has a speed of 1.5 meter per second. Find the kinetic energy and the potential energy of the cyclist. The mass of the cyclist and bicycle is 40 kg. Okay, that means that cyclist means combined weight is given, separate mass is not given. If they are giving separate mass, then while calculating the values, you have to add that values. Okay, so this is also very straightforward question. So here they are saying the height of the slope, that is nothing but h, height, that is given 6 meter. Okay, and then they are saying its speed, v is given 1.5 meter per second. After that they are saying find the kinetic energy and potential energy of the cyclist. The mass, that is total mass, is given how much? 40 kg. Okay, so now they are asking kinetic energy. So write directly formula. Kinetic energy is nothing but half mv square and potential energy is nothing but what? mgh. So by using these two formula we will get the answer. So here half, mass is 40, v is 1.5 square. Okay, so this will become 20 into 225, that is 2.25. Then if you multiply here, you will get the answer 45 joule. Okay, this is nothing but the kinetic energy. Okay, then potential energy is nothing but mgh. Mi will take it as 40. As g value is not mentioned, I will take it as 0. I will take it as 10 and height is given 6. Okay, so here this is nothing but what? Potential energy we will get. So 2400 joule is the potential energy. Okay, take a screenshot. I hope you are getting these questions and their answers. Can you able to solve? Can you able to do, Yasir? Indivar is there, Rujul, Varad, Krishna, Mohammed, who all are there? Okay, leave it. Chalo. Next question. A man pulls a block. A man pulls a block with a force of 300 Newton through 50 meter in 60 seconds. 50 meter in 60 seconds. Find the power used. Find the power used by him to pull the block. What, Mohammed? What you are saying? I am not able to. Okay, chalo. So I will repeat this question. A man pulls a block with a force of 300 Newton through 50 meter in 60 seconds. Find the power used by him to pull the block. Okay. So try this question. Can you able to solve? Check what you will get the answer. Yes, someone can type the answers, those who got. Oh, repeat the question. Okay. We'll repeat. A man pulls a block with a force of 300 Newton through 50 meter in 60 seconds. Find out the power used by him to pull the block. Okay, to pull the block. So here we have to, they gave here force. Okay, force is given. I will write down the given quantities. Okay, so here force is given 300 Newton. Okay, and distance is given, that is S, that is given 50 meter, and time is given 60 seconds. Correct? Time is given 60 seconds, and they are asking power. Okay, I know that power is nothing but what? Work by time. Okay, in last session only we did work by time. This is nothing but power. Okay, but here work done is nothing but what? Here power is nothing but work done by time, and work done is nothing but force into displacement divided by time. Getting this? So I know force, know the displacement, know the time. So force is nothing but 300, S is nothing but 50, and here time we have 60, 0 get cancelled. So 6 1s are 6, 6 5s are 30, 0. Here 250 watt is the power, or yeah, this is nothing but what? Your power. Getting this? How to substitute the formulas if the values are given like this. Now I hope everyone took the screenshot. I'm sure you are getting this. Yes, correct. Okay, chalo. Next one, write down a 50 kg man. A 50 kg man. A 50 kg man moved 25 steps up. A 50 kg man moved 25 steps up in 20 seconds. In 20 seconds, find his power, comma, in each step is 16 centimeter high. Each step is 16 centimeter high. Okay, so I'll repeat this question. A 50 kg man moved 25 steps up in 20 seconds. Find his power if each step is 16 centimeter high. Okay, so here we want to calculate the power of this man. Okay, so here the thing is that same formula we are using to calculate the power. Okay, try to understand the question here. Here a man, okay, that person is of 50 kg and he is stepping up. Okay, he is moving from the steps. He took 25 steps. Okay, and each step is nothing but what? 16 centimeter in height. This is also 16 centimeter in height. Can you getting this? Okay. So here, if the mass of that person is 50 kg, then how much his total distance covered or total height covered? So total height is nothing but they are saying this is 25 steps. Okay. 25 steps into 16, no? So whatever the answer you are getting, that is in terms of centimeter. So this, after doing this calculation, you get the answer 400 centimeter, and if you divide by 100, then you will get here 4 meter is the height he covered. Okay, and total time period is given 20 seconds. Okay, so once this is given time, means we got mass, height and the time here, then power is nothing but again what? Power is nothing but work done by time. So as he is jumping from, as he is going from step 1 to step 2, it's vertical. His mass is what? Acting vertically downward. So work done is nothing but mgh divided by what? T. Okay. So we have to substitute the formula like this, and mass is here 50, g you can take it as a 10, and height we have 4, and time period we have a 20. Okay, so here we get 1 by 2, this is 2, so you will get 100 watt is the power. Can you getting how the height is given indirectly here? Okay, so you can take a screenshot. Can you all getting? Check Mohammed your calculations. You can check your calculations because answer is correct 100. Okay, next question. Write down. Everyone took a screenshot of this. Okay, so write down next question. Calculate the power. Calculate the power of a pump. Calculate the power of the pump that can lift 200 kg of water, that can lift 200 kg of water through a height of 6 meter in 10 seconds. 6 meter in 10 seconds. I will repeat this question. Calculate the power of pump that can lift 200 kg of water through a height of 6 meter in 10 seconds. Okay, try this question. Try these questions. Check what is the answer you are getting. Okay, how much is the answer? Check. Who got the answer? Here mass is given how much? 200 kg. Mass is given 200 kg. Then height is given 6 meter. Height is given 6 meter and time is given 10 seconds. Okay, time is given 10 seconds. We are using the same formula. Okay, so mgh, m is nothing but here 200, g is 10, h is nothing but 6 divided by 10. This 10 and 10 get cancelled. 1200 joule. 1200 joule is the answer for this question. And I hope everyone got the same answer. Yes, write the unit joule. Okay. Okay, write down the next question. Write down the next question. IMP question. Write down. The bob of pendulum is released. A bob of pendulum is released from a horizontal position. From horizontal position. The length of the pendulum is 1.5 meter, comma, what is the speed with which the bob arrives at the lowermost point, comma, given that given that it dissipated 5%, given that it dissipated 5% of its initial energy, 5% of its initial energy against air resistance, against air resistance. Okay, so I will repeat the question. The bob of pendulum is released from horizontal position, full stop. If the length of the pendulum is 1.5 meter, what is the speed with which the bob arrives at a lowermost point? Given that it dissipated 5% of its initial energy against the air resistance. Okay. So whenever you are releasing the bob of pendulum from the horizontal position, it falls vertically downward by the distance which is equal to the length of the pendulum. Okay. So that length of the pendulum or the height covered by the bob of pendulum is nothing but h. Okay, and that height is nothing but the length of the pendulum. That string is having the length L, and that L length of the pendulum is given 1.5 meter. Okay, and they are saying what is the speed with which bob arrives at a lowermost point. Okay, so actually this is what the bob, okay, and this is the length L, okay, or we can say that h. When you release, then it will reaches somewhere over here. Okay, and while coming from horizontal to lowermost point, means here, this is what its mean position. So when it comes to its lowermost point, it is that saying the energy dissipated 5% of its initial energy. So initially it is at potential energy because it is at height, certain height we kept, and it possesses potential energy. Now it is in motion, that means now it is possessing kinetic energy. So we can say that kinetic energy is nothing but 100 minus 5% of energy, initial energy, that is nothing but your potential energy. And we can write here 95% of potential energy. इतना एनर्जी क्या हो जाता है? Now it is there in the bob of pendulum. Now it is very easy. So we have here kinetic energy half mv square. This is 95 divided by 100, and this is mgh. M and m's get cancelled. So v square transpose to this side. 2 into 95 divided by 100. Okay, and g you can take it as a 9.8 to get the correct decimal. Okay, 9.8, and this h is nothing but 1.5. So v, that means you can take a square root on both the sides. So 95 into 9.8 into 1.5 into 2 divided by 100. So 100 you can take it out as a 1 by 10 and perform this calculation. Okay, check the calculation, what you will get. Check the calculations once. 100, 1 by 100 you can take it as a 1 by 10. 1.5 into 2 is nothing but 3. Okay, because 15 twos are 30, and adjust the decimal, that is 3. 3 into 95 into 9.8. So if you calculate and if you take a square root, okay, so you will get the answer around 5.3. Approximately you will get the answer 5.3 meter per second. This is what the velocity we will get. Okay. check. Everyone is getting the answer. Check once. I am waiting for correct decimal places. Check your answer. Okay, you got the correct answer. Now write down the question. Write down the next question. The kinetic energy of an object, kinetic energy of an object of mass, kinetic energy of an object of mass m, of mass m, moving with a velocity of 5 meter per second, 5 meter per second is 25 joule, is 25 joule, full stop. What will be its kinetic energy? What will be its kinetic energy when its velocity is doubled? When its velocity is doubled? Question mark. Next, what will be its kinetic energy? What will be its kinetic energy when its velocity is increased 3 times? What will be its kinetic energy when its velocity is increased 3 times? Okay, I will repeat this question. The kinetic energy of an object of mass m moving with a velocity of 5 meter per second is 25 joule. What will be its kinetic energy when its velocity is doubled? Okay, what will be its kinetic energy when its velocity is increased 3 times? Okay, so here given is the velocity and even they gave the kinetic energy of the body. Okay, so here a very important thing, they are saying to calculate the kinetic energy when velocity is doubled, and again they are asking to calculate the kinetic energy when velocity is get tripled. Tripled means 3 times. Okay, so our first aim is to find out the mass, otherwise we cannot calculate the kinetic energy over here. Okay, so here the given velocity v is given 3 meter per second. Okay, so not 3, it's 5 meter per second, and kinetic energy is 25 joule. Okay, and we know that kinetic energy is nothing but half mv square, because here they are asking what will be the kinetic energy. Okay, so kinetic energy is nothing but here 25 half m, I don't know, v is nothing but here 5 square, that is nothing but 25 only. Okay, m into 25 equal to 25, 25 and 25 get cancelled. Okay, and mass you will get it as a 2 kg here, getting? So just transpose this half to this side, so mass you will get it as a 2 kg. Okay, once you will get the mass, then they are asking when velocities get doubled. Okay, first case क्या है, velocity is get doubled. Initially velocity is what, 5, now velocity is doubled. Doubled means what? 5 into 2, that is nothing but 10 meter per second. Okay. So in this case, you have to calculate the kinetic energy. So kinetic energy is again half mv square. So half mass is given 2 and v is nothing but 10 square. 2 to get 100 joule. This is nothing but what your kinetic energy when its mass is 10 mass is 2 kg and when velocities get doubled. Getting this? Can you get? Everyone is getting the question? Okay, copy this. I think you can take a screenshot also. Okay, so write down the next question. Okay, write down. A certain force acting on 20 kg mass, certain force acting on 20 kg mass changes its velocity from changes its velocity from 5 meter per second to 2 meter per second. 5 meter per second to 2 meter per second. Calculate the work done by the force. Calculate the work done by the force. Okay, I'll repeat this question. Certain force acting on a 20 kg mass changes its velocity from 5 meter per second to 2 meter per second. Calculate the work done by the force. Okay, so work done we have to calculate. we learn work energy theorem. Okay, change in kinetic energy is also work done. Okay, and here mass is given and initial to final velocity is also given, and here velocity, final velocity is what decreased. Okay, and initial velocity is here 5 meter per second. So we can solve. So here answer you will get negative maybe, huh? Okay, chalo, we can do this. So here you can write down the given quantities. Here mass is given of 20 kg. Okay, then velocity changes from 5 to 2. So u is nothing but here 5 meter per second and v is nothing but 2 meter per second. Can you get it? Okay, they are asking us to calculate the work done, and change in kinetic energy is also work done. So I will write kinetic energy final minus kinetic energy initial. Okay, so here half m v square minus half m u square. So you can take half m common and v square is nothing but here 2 square minus 5 ka square. Okay, you can expand or you can use identity a plus b, a minus b, or you can write it as 1 by 2 and mass is here 20. So 4 minus 25. Okay, and here 2 tens are 20. So 4 minus this is 21, minus 21. So answer is minus 210 joule is the work done. Okay. So here the negative sign indicates that work has been done in slowing this body, because final velocity becomes what 2. So slowly its speed is what get decreasing. Okay, copy this. हो गया? चलो, write down the next question. Write down next question. A certain household has consumed 250 units of energy. A certain household has consumed 250 units of energy during a month. How much energy is this in joules? How much energy is this in joules? Okay, so try to solve this question. I will give you 2 minutes. Try this. हो गया? चलो next one. It is very simple. You can try at home. Now write down next question. Work done in stretching a spring of constant K. Work done in stretching a spring of constant K by X is half kx square, is half kx square, full stop. The work done by the above spring, the work done when above spring is stretched further from x to 2x is then this is MCQ. Write down first bit. Yes, I will repeat. First bit half kx square, second kx square, third 3/2 kx square, fourth option 2kx square. Okay, I will repeat this question. Work done in stretching a spring of constant k is half kx square, full stop. The work done when above spring is stretched further from x to 2x is and then write down first bit means first option half kx square, second option kx square, third option 3/2 kx square, fourth 2kx square. Okay, now everyone have a question with you. Options are with you. Okay, who is asking? First option is half kx square. Okay, half kx square. Now here work done in stretching the spring constant k by x. Okay, work done and that work done is nothing but half kx square is given. The work done when the spring is stretched from x to 2x. Okay, now here the scenario is given. एक स्प्रिंग है, उसका वर्क डन इज गिवन half kx square and now initially the spring is at this position x. Okay, and now it is stretched further so that, or we can say that it is stretched further from mean. From here this distance is nothing but 2x, means it is reached to 2x over here. Can you getting this? Okay, so now they are asking whenever you are stretching from x to 2x, what is the correct option? We have to find out. So here work done by the spring is given half kx square and here k is given spring constant kx square. Okay, so we got here work done is given kx square. So change in this is how much? Check here. Work done can we write it as see half and spring constant will remain same. Now it is moved from x to 2x. Okay, so suppose if I am taking this final as a x2 and this as a x1, this is what? Whole bracket square. Okay, not whole bracket square, we can take x square, no? Yeah, so we can write x2 square minus x1 square, like this we can write. Now here positions are what? Different, no? So we can write here 1/2 k. x2 is nothing but what here? 2x whole bracket square minus here x whole bracket square. So half k. So we have here 4x square minus x square, that is 4x minus 1x is nothing but 3x. So half k into 3x square. So answer we will get 3/2 kx square. This is nothing but work done when you stretch from x to 2x. So which one is the correct option? Check here. Yeah, option 3 is the correct option. हो गया? चलो next one. Write down next question. Everyone is getting how I did? Okay. Take a screenshot of this. Now write down the next question. Two springs with a spring constant of 400 Newton meter and 100 Newton meter are stretched in such a way that both have same potential energy, full stop. What will be the ratio of elongation? In first spring to the second spring? Okay, so I will repeat this question. Two springs with spring constant 400 Newton per meter and 100 Newton per meter are stretched in such a way that both have same potential energy. What will be the ratio of elongation in first spring to the second spring? Okay, so potential energy we know that half kx square. I will solve and after this I'll stop. Okay, so potential energy of the spring is nothing but u half kx square. Okay, so here here they are saying the both springs have a same potential energy. Okay, so potential energies are same, so u1 is equal to u2 and we can say here half k1 x1 square is equal to half k2 x2 square. Okay, so here k1 and here half and half get cancelled and here we can take x1 square by x2 square and that you can transpose k2 by k1 and here k2 by k1 is given, no, that is 400 Newton per meter and this is given how much? 200 or sorry not 200 100 Newton per meter. Newton per meter, that is the unit. Okay, and if you take this, oh sorry, k2 is I think 100, no, 100 or some, what is given? Yeah, 400. First spring is 400, no, first is 400. k2 is 100 and this is 400. So this is get cancelled and answer you will get it as x1 square by x2 square 1:4 and if you take a square root on both the side x1 by x2 is nothing but 1/2. Okay, take a screenshot. Those who have a doubt I will explain it later. Okay, copy this, take a screenshot. Okay, I hope you got this session. So I will end this.